Today we are going to learn about mastering model serialization with JSON and Pickle. We will explore how to efficiently save and share trained models using JSON and Pickle in Python, enhancing your data science and machine learning skills.
In this section, we introduce the concept of model serialization, a technique used to convert a trained machine learning model into a format that can be easily stored and later reconstructed. Serialization is crucial in data science, as it allows models to be saved and shared, ensuring that they can be reused without retraining. We'll explore two popular serialization formats in Python, JSON and Pickle. Each has its unique features and applications, which we'll cover in detail. By the end of this video, you'll have a comprehensive understanding of how to use these tools effectively. JSON, which stands for JavaScript Object Notation, is a lightweight data interchange format that's easy for humans to read and write, and easy for machines to parse and generate. In Python, JSON is used extensively for data serialization due to its simplicity and interoperability with various systems. JSON is structured as a collection of key-value pairs, much like a Python dictionary, and can represent complex data structures as nested arrays and objects. In Python, the built-in JSON library provides methods for encoding and decoding JSON data. We'll delve into using this library effectively, explore its common functions like JSON.dump and JSON.load, and discuss scenarios where JSON is the best choice for serialization.
Pickle is a Python-specific serialization format that allows you to serialize and deserialize Python objects efficiently. Unlike JSON, which is text-based, Pickle converts objects into a byte stream, which is then stored in files. This makes it highly efficient for serializing complex Python objects, such as custom classes and functions. However, Pickle's reliance on Python-specific formats means serialized data may not be as portable as JSON. We'll discuss how to use Pickle's dump and load methods, explore its advantages, such as speed and flexibility, and highlight important considerations, including security risks associated with untrusted data sources. Understanding the differences between JSON and Pickle is crucial for choosing the right serialization method for your project. JSON is text-based and language-independent, making it ideal for web applications and data interchange with non-Python systems. It excels in readability and compatibility but can be less efficient for complex Python objects. Pickle, on the other hand, is highly efficient for Python-specific data and supports a wider range of Python objects. However, its byte stream format can pose security risks if not handled correctly, as it can execute arbitrary code during deserialization. We'll explore these differences in detail and provide guidance on when to use each method based on your specific needs.
In this section, we'll walk you through the process of serializing data with JSON and Python. We'll start by preparing your data, ensuring it's in a format compatible with JSON. Using the JSON library, we'll demonstrate how to serialize data to a JSON file using JSON.dump and to a JSON string with JSON.dump. We'll also cover reading JSON data back into Python using JSON.load and JSON.loads. Handling complex data structures, such as nested dictionaries and lists, is an essential skill, and we'll show you how to manage these effectively. Additionally, we'll discuss common pitfalls, such as data type limitations, and provide troubleshooting tips to ensure smooth serialization.
JSON offers several advantages for data serialization, including its human-readable format and compatibility with various programming languages, making it ideal for data interchange in web applications. Its simplicity and ease of use are significant benefits, allowing for quick serialization of simple data structures. However, JSON has limitations when dealing with complex Python objects, such as custom classes and functions, which require additional handling. JSON's text-based format can also lead to larger file sizes compared to binary formats like Pickle. Security is another consideration, as JSON data should be validated to prevent injection attacks. We'll explore these aspects in detail, providing insights into when and how to use JSON effectively. Pickle is a powerful tool for serializing Python models, especially when dealing with machine learning. We'll guide you through the process of preparing your models for serialization, ensuring they are compatible with Pickle's requirements. Using Pickle.dump, we'll demonstrate how to serialize a model to a file, and with Pickle.dumps, how to serialize it to a byte string. We'll also cover deserializing models using Pickle.load and Pickle.loads, ensuring you can accurately reconstruct your models. Handling custom Python objects, such as classes and functions, is a unique strength of Pickle, and will provide best practices to ensure successful serialization. Troubleshooting tips will be included to help you overcome common challenges.
While Pickle is a powerful serialization tool, it comes with significant security risks due to its ability to execute arbitrary code during deserialization. This makes it vulnerable to attacks if untrusted data is loaded. To mitigate these risks, it's crucial to validate input data and only load Pickle data from trusted sources. Alternatives to Pickle, such as JSON, should be considered for sensitive data where security is a concern. We'll discuss how to secure your serialization process, including best practices for safety, and provide real-world examples of security breaches related to Pickle to highlight the importance of vigilance. Choosing the right serialization method for your project involves evaluating several factors, including the complexity of your data, the need for cross-language compatibility, and security considerations. JSON is ideal for projects requiring interoperability and readability, while Pickle is suited for complex Python-specific objects. Security is a critical factor, especially for applications handling sensitive data, where JSON may be preferable due to its safer format. Performance is another consideration. Pickle's binary format offers speed advantages, but JSON's text-based format ensures broader compatibility. We'll guide you through making an informed decision by assessing your project's specific needs and balancing these considerations effectively. Model serialization is essential in various industries, from finance to healthcare, where machine learning models are deployed in production environments. JSON's ease of use and compatibility have made it popular in web applications, while Pickle's efficiency is valued in data-driven industries requiring complex model handling. We'll explore case studies demonstrating the effective use of JSON and Pickle in real-world scenarios, highlighting their impact on data science workflows. As serialization technology evolves, understanding these tools' roles in future trends will ensure you stay ahead in the field. We'll discuss how serialization is shaping the future of machine learning and data science. Serialization can present several challenges, particularly when dealing with large datasets or complex objects. Efficiently managing these challenges is crucial for maintaining performance and reliability. We'll address common issues, such as handling memory limitations and optimizing serialization speed. Deserialization errors can be particularly perplexing. We'll provide tips for diagnosing and resolving these issues effectively. Security challenges, especially with Pickle, require careful attention and will offer strategies to mitigate risks. By the end of this section, you'll have a toolkit of troubleshooting techniques to ensure smooth serialization processes in your projects. As we conclude, let's recap the key points from our exploration of model serialization with JSON and Pickle. We've covered the fundamental differences between these two methods, their respective use cases, and the advantages they offer. Security remains a critical consideration, particularly with Pickle, and we've emphasized best practices to safeguard your serialization processes. With a solid understanding of these tools, you're now equipped to choose the right serialization method for your projects, ensuring efficiency and compatibility. For further learning, we recommend exploring additional resources and tutorials to deepen your understanding. Thank you for joining us, and we hope you're ready to apply these skills to your future data science endeavors.